All right, so this is 124, the advanced ethical hacking. We're going to be doing more advanced attacks than you did in 123, and you'll be writing some of your own attacks. We're not going to get very deeply into any programming, but you'll learn a little bit of Python, and we'll go quite a bit in how to use Metasploit in more detail and other things. So you'll be doing attacks, and the idea is this covers some of the material needed to get the OSCP certification. Several students are now studying for. I don't think you could necessarily get that certificate just after taking this class, but it does cover most of the techniques. The thing about the OSCP certification is you not only have to know the techniques, you have to be pretty fast at them. So you have to practice them, because you have something like 24 hours to hack into 7 servers. In order to get the certification, it is not a multiple choice test. You have to really hack into servers, which is pretty cool. And that's why it's very widely respected. So we're going to talk about phone networks and computer networks and the usual stuff, how to scan, identify vulnerabilities, and exploit them. There's a textbook. There are 2 textbooks, in fact. This one here is the main one we'll follow, Georgia Weidman's Introduction to Hacking. And this is one I've heard people say was the one that they used to prepare for OSCP certification. So we'll cover a lot of the topics in here. I'm also got some violent Python projects. You don't really need to buy that book, but that is where a lot of it came from. It's a book that teaches you how to do very simple programming for attackers, where you do not bother very much with error handling or fancy stuff that makes commercial code good. You just learn how to make an attack work once, which is mainly what pen testers do. If you actually want to write a product and make 1 million copies like Microsoft Office, there's a whole burdensome, difficult form of coding where you have to have comments and error handling and many modules all working together. But hackers don't bother with any of that. They make one attack work once and the job is done. They don't worry about anything other than making it work. So that's what we're going to do. There are quizzes after the first few weeks. The first one is on September 14. They're online. You have to finish them before class. So first 2 of them are due online. The online course is set up and the first 2 quizzes are there. I'll add more as we go ahead. You can watch this class remotely on the live stream at that URL. And after the live stream, it then turns into a YouTube video and is posted up on this page. So you can watch stuff at another time if you want to. And there's the typical schedule covering chapters and having quizzes and such. Here's the grading, which is the same as all my other classes. You have quizzes and projects and a final exam for a bunch of points. 90%'s an A, 80%'s a B, and so on. The final exam is comprehensive, but you don't have to take the final exam if you do extra credit projects. You can pretty easily get enough points to not need it if you do all the rest. And so of course you're learning dangerous skills here. If you actually go hack somebody's website without permission, then you're breaking the law and you'll get in trouble and I won't be able to save you. And if I find out about it, I'll throw you out of the class, but that will be the least of your problems. So if people are copying homework or otherwise cheating, I generally throw them out. Let me know if anything fishy is going on. But if you can't be trusted to not cheat on your homework, then you really should not be trusted with these hacking techniques. Because you really can get in trouble with this stuff. But it's a whole lot better to actually get a job. All right, you do not have to attend class. You don't get points for attending, and you don't lose points for not attending. All I care is that you learn it. All your grade comes entirely from quizzes and homework, which is all online. So some people are far away and attending by live stream. And if you don't find the lectures useful, you can ignore them and just read the book. As long as you learn it somehow, that's all I care about. If anybody needs any special consideration for a handicap or anything, let me know. I'll do what I can to help you. So if anybody came to add, there's obviously plenty of room. I'll put up ad codes later. I already emailed ad codes to everybody that was on the waiting list, but if anybody wants to add beyond that, that's fine. And you are in a recording studio. They are recording this room, so if you don't want to appear, you should like hide in the corner or view the live stream. And there's a photo release going around. If you, hopefully, I want you to sign one of them if you haven't already signed one in a different class, so that they have some cover in case somebody gets upset about being recorded. They do record the audience sometimes, and me sometimes, so there will be a picture of you sitting there falling asleep in class or something. All right, so I don't really have any plan for a normal lecture today. I just plan on demonstrating the first several projects. The whole point of this class is hands-on projects. I will cover some chapters in the book later, covering the basics of how to use Linux, the basics of programming and Metasploit and so on. But for tonight, you might as well just start doing it. So I think I'll just follow in my original order here. This is what I teach a lot of classes. This is the violent Python part. if you have never done any programming at all, the first language to learn is Python, because it's easy enough to do pretty much anything in Python, and that's because other people have already done all the work. By the way, there's a new version of Python called Python 3, and it's useless. Don't waste your time, use Python 2, because all of the libraries are written only for Python 2. It's sort of like IP version 4 and IP version 6. People made the new version, and nobody cared. They all just kept using the old version, and a few people are like mad about it, but 90% of everybody just keeps using the old version happily and ignores the new version. There are a couple of good features in Python 3, but 90% of the things you want to do won't run in Python 3. So unless you're sophisticated enough to write stuff all yourself, you'll be better off just using Python 2. So let me see if I have another window open or what. Looks like I don't. I'll open another now. All right. And make it bigger. All right. So you can install Python on any operating system. You can even put it on Windows and such and use it. But in this class, you're going to need Kali Linux anyway, so I think most of you already have a Kali Linux VM from taking previous classes in security. If not, Project 3 shows you how to get the machine started. Get a Kali Linux machine running. You'll need it. And then if Kali Linux, like all versions of Linux, has Python built into it, you can just type Python, and you get an interactive shell, so you can put in commands now, like 1 + 1, and it's 2, and so on. You can use it this way, just directly. Maybe I'll shut that while they're being noisy. And go ahead. If it gets too hot, I can open it again. Anyway, so you can use Python this way to test out 1 or 2 commands and check something. Most of the time you want to write programs. One annoying thing is, when you're done using this, you have to use exit and open and close parentheses to get out, which is pretty frustrating until you get used to it. This is because it has to be a command, it's a function, and it has to have the parentheses to indicate it's a function. Otherwise, it's a syntax error. Anyway, let's make a banner grabber here. I'm going to just copy this code, and then we'll talk about it. You can copy and paste, as long as you have VMware tools. I'm going to go to some better directory, like here. Make it dir 124, that'll do. Let's go here. All right. All right, so here it is. By the way, I'm going to get rid of the colors. Okay. So here is the Python code that connects to a server. This imports the socket library. This is how it always works. You find somebody else who wrote a library that did all the work for you. Then all you have to do is import their library and use what they wrote. That's why Python's easy. So somebody wrote the socket library, which does Berkeley Standard Network Sockets, which is what all the internet was based on. This is how the internet was made, finding these Berkeley Standard sockets. And the way you use it is you call s = socket, here, and that creates a socket object. Python is actually a very advanced language. It's object-oriented, and you don't really need to know that or understand it to do simple things, but if you proceed, you can actually make multi-threaded code and all sorts of awesome stuff in fancy Python, but we're only doing simple Python. So this creates a socket object. This connects to a server. You have to have 2 sets of parentheses here, which is a little screwy at first, because the person that wrote this method, instead of making it have 2 parameters, it has 1 parameter, which is a tuple containing 2 elements, just to give you a headache. But anyway, you put the URL here, and you put the port number there, and it will now connect to that server on that port. So this will call my server on port 22. Then it'll print whatever it got back, up to 1024 characters, print S receive, so it sends a TCP handshake to the server. If any data comes back, it prints it out here, and then it closes the connection with sclose. That's it. That's all this does. Simple connection. Same thing you could do with telnet or netcat from the command line. So that's the simple program. And to run it, you type Python and then the name of the program. And so it connects to my server, and it gets the server banner. Now, SSH is a process. I think they're quieter, and I'm going to open this to make it cooler already. Yeah. All right. Because SSH is intended to be used by humans at the command line, where you're typing commands, it has a banner. When you connect, it prints out a banner so you know it's ready. So as you see here, it tells you I've got a default OpenSSH installation running on an Ubuntu server. That's what that thing is at attackdirect.samsclass.info. All right. So you can get that. Now, the next thing is, so let's try connecting on port 80. So let's modify my script. I'm going to copy grab2, grab2.py. CP is copy in Linux, and then nano is the easiest editor to use. If you actually know how to use VI, that's even cooler, and it will impress people, but I can't ever remember how to use it. I'm a wimp, and I use Nano. And so I'm just going to change that script to connect on port 80. All right. And run that one again. Grab 2. If I can type. Okay. Now, the problem with port 80 is port 80 is not intended to be used in this manner. It's not a human that types in commands one by one. Port 80 is supposed to be used by a web browser that automatically sends up a request. So when you connect on port 80, it just sits there. It finishes the handshake and does not send you any data. So there's nothing to see. So this is kind of annoying. So now, if you're going to think about making a port scanner, which is where I'm headed here, then you don't want to just freeze up forever. And by the way, the default timeout is something ridiculous, like 120 seconds. So this is frozen for minutes. So that's for the birds. So we can improve this script. Let's go here and set the timeout, which is socket set default timeout. All right. I could also restrict it just to S, but that should do it. So I can put in that. That will set the timeout to 2 seconds. So now, when I run that, it doesn't take forever. It times out. Now, it just prints an ugly bunch of error messages when it crashes. This is because I've written really sloppy code. Now, you may not want to do this, but if you want to be a little more professional, you can handle the errors. So let's try that. Let's copy this to another one. To grab 3.py. So this also shows you how Python handles blocks. This is one thing that really frustrated me about Python because I started knowing C. So this part can hardly fail. It just creates an object. This is the one that might fail when I connect to a server. So you try this. Now you have to indent the next line. It will try to do that, and if it fails, it will do accept. There. This is how Python works. If you for if statements and while statements in any condition, you have a command and then a colon, then the next line is indented, and when the indentation stops, it's the end of the block. In C, you have these curly braces, which is what I was used to, and white space doesn't matter at all. So this is good. If I put an extra space here, it'll be a syntax error. So let's see how that one works. Now if I run that one with Python grab 3, got to spell Python better though. Grab 3, it connects and times out after 2 seconds, shows up there. But the reason I wanted to handle the error is because of this. If I change to a port that's closed, let's change it to port like 81. Now I get the error because now it tries to connect and it can't connect. And if I didn't have that try in there, let's change my grab 2 to do that so I can show you the difference. If I connect this, take this script without the error handling, and I make it go to port 81, it's going to fail to connect and just give me blep, all sorts of default error messages, which are much less helpful than an error I might choose. Anyway, that's a couple of very simple things you can do in Python. And the next thing you might want to do is use variables. So let me make this one. I'll bring up my virtual machine and move it to the right a bit so I can see what I'm doing. Let's get rid of this one for the moment. All right, so let's copy grab 3 to grab 4. And I'll grab 4. Okay, get rid of the stinking colors. Okay, so what I'm going to do here is use variables for the name and the port, because then I'll be able to modify them and make them go through loops and stuff. So instead of literally putting it in that string, I'm going to copy this. If you care, Control-K copies and Control-U pastes in Nano. There's more complicated keystrokes in VI if you know that. So target equals that. All right. And T-port equals that. All right, and now when I connect, I can use the variables instead. Target, T port, and let's connect to port 22 again so I can see what happens. So it'll connect. I've just used variables for it at this point. Unless I made a mistake, that should run. Grab 4. Okay, and I failed. I'm missing a quote. End of line when scanning string literal. So let's take a look. Indeed I am. I need a closing quote there, or it's no good. All right, so let's try that one. And there it goes. Connection gets the banner again. So now I have variables. Now I can get user input. Here's how user input works. You use this thing called raw_input. And see if I can get this thing to stick on me. All right. So this will print this prompt, and whatever the user types will go in this variable called target. So let's try that. Copy grab 5, grab 6. So maybe it's grab 4. Yes, it is. All right. Copy. Grab 5.py, nano, grab 5. This, by the way, is something I highly recommend. Don't write one program and keep changing and changing and changing it, because very often you make a mistake and you make 3 more revisions before you figure out it's a mistake, and you wish you could go back to the one that was working. So I have this habit of 1, 2, 3, 4, 5, 6. You can always throw them away later. But when you're developing, only add a few lines at a time, because then if it crashes, you know what part is bad. The number one mistake beginning programmers always make is they write a whole page of code and nothing works, and now they're lost, because they've made 6 mistakes in that page. Make just a couple of lines that work, add a couple more lines that work. That way you know what you're doing. You get to the end faster that way than trying to write too much. Anyway, so going in here, I want to make it use raw input. Raw input of target URL and raw input of port. There. Oops, yep, thank you. Better spell raw correctly or it's not going to let me get away with it. Let's see if that runs. Python, grab 5. Okay, URL is going to be attack, AD will work, .samsclass.info. I made another alias for it because I'm too lazy to keep typing lots. Okay, 22, and it failed. So notice what happened here. If I can figure out how to move this there. Transport endpoint is not connected. That's a really unhelpful error message. And I can tell you what happened, but you'd have a hard time figuring out from that. This one here gave a better error. When I did it here, it actually said an integer is required, and that's the problem. I may have a second problem in my script here, but the one I expected was, unfortunately, Python has variable types, but you don't declare them, and they're not simple to control. It guesses. This is true of PHP and other weakly typed languages, and it can lead to hilarious and severe security problems. But what happens is this expects a string here and an integer there. But raw input always interprets stuff as strings. So I need to convert tport to an integer. That's the problem I know about. This other thing about it being able to connect, I'm not sure about. But to make it an integer, you just use int here. So int of that will take the text that comes in, and I guess I'll make it look prettier by doing that. All right. So now it'll take the raw input that's a string and convert it into an integer. Let's see if this one runs or not. I might have some other problems. So it's ad.samsclass.info and port 22. Now it works. Okay. So I'm a little surprised I got that goofy message. It didn't even tell me string where integer was expected, but that's the thing. Default Python error messages tend to be very confusing. That's why I say don't put in 20 lines of code before you run it. Put in just a few lines at a time so you know where the problem is, because the error messages will not help you much. So now I can connect to any server on any port by typing them in here. So I've made a very simple little port scanner. And that's all this project is. Get that stuff working, turn in a couple images, and that's your first Python script. Now there's a pattern here, which I learned from Vivek Ranachandran, who is a very famous online teacher, which I found to be very helpful. I give you a simple project where I tell you exactly what to do, and then you have a challenge. I move the challenge down here to the extra credits. And so you'll find another service on my server with a port number ending in 1000. So try them. You could just try them one by one, or if you're fancy, you could make a loop. And then there's port knocking. My server, port knocking is a really old technique used by malware where you can have a secret backdoor into a server. If you have an open port, it'll reply to a SYN with a SYN-ACK. Leaving, all right. Anyway, if you have a closed port, it just replies with a reset. In order to hide your port, you have a listening process that waits for a particular pattern of knocks, like a SYN on port 7000, a SYN on port 8000, and a SYN on port 9000, all within a few seconds. And if it gets those, it opens another port for just a few seconds. So anybody that's scanning ports randomly or in series will never find it, but there is a secret way in. This has been used for a long time. There was a survey the Register had about 5 years ago when they surveyed network administrators, server administrators, and they said, how many of you have a secret backdoor into your network? And 80% of them do. And they said, how many of you would be fired if the boss found out? And 80% of them said they would be fired. Because it is the state of this business, and this has a lot to do with the psychological problems of our business, that many technical people work for bosses who do not understand technology. So the boss will say, absolutely not, you can't have a secret backdoor into the network, you can only have the official network. Then when you're surfing in Hawaii, he'll call you, oh my God, the server's down, you have to fix it. And he'll say, in fact, I do have a magic way I can't tell you about. Because you'll be fired if you don't have the backdoor, and you'll be fired if you do, and this is the normal situation. So anyway, this is one of the many techniques they use to do it. So if you send a SYN to 3100 and a SYN to one of these other ports, then it'll open port 3003 briefly. So you can write a script that tries various combinations until you find it, and these are the challenges. And when you're done, you'll fetch a banner you can see, and you can turn in a screenshot of that. So you can do that. You have several weeks to do it, and after class, I'll go to the lab and help people that want to do it tonight. But I try to make almost all the projects work this way, where there's one part where I tell you what to do, and then a challenge where you have to extend it. Here, you don't even need to make a loop. You could just type in numbers and try them one by one, or modify your script over and over, because there's only about 10 choices in each case. But if you want to make a loop, that's fine. Yeah. Looks like you have the question. Oh, good. Okay. All right. So that's the first couple things I wanted to show you, and let me point you to the next ones. That's project 1. Project 2 is more of the same, where you use HTTP requests. So remember, we connected to the server on port 80, and we got nothing. It connects, but it just sits there. That's because port 80 is not intended to be used by a human typing commands at a terminal. It's intended to be used by a web browser, and the web browser knows how to correctly send HTTP requests. So you can do it too, but you have to add a couple lines to your program. So let me make this one. I'm going to copy, say, grab 2 probably to HTTP 1. And let's get rid of the stinking colors. All right. And make it so it fits on the screen along with the example. All right. So I've got a socket and the default timeout. I've got a target. I'm going to just make my target. I'm just going to make it fixed of ad.samsclass.info. For now, that'll do. And the T port will be 80. I'm not going to worry about HTTPS connections. Those are more complicated. I'm just going for standard old HTTP here. So now I connect to the target and the port. Let's put it here. Okay, now there's no point trying to print the received data because there won't be any. I have to send more data before I receive anything. So let's put that in here. You do s.send. And now I can send a request. And the request has to be a correctly formatted HTTP request. And the simplest HTTP is head. There are about half a dozen HTTP methods. The most common ones are head, get, and post. Head just tells you information about the server. Get fetches a web page, and post sends up data, like a name and password. And those are the ones you use most commonly.
Use the comma.
Why, thank you. Good. The comma will break it. Got to have a dot for the send method of the head object, so it's of the S object. So it's head/HTTP/1.1. Then you have to have a carriage return, and then you have to have the host. And I'm going to put plus target here. All right, and now carriage return, carriage return. Okay, that will send a head request to the server. And then it'll print what comes back from that. And if I have formatted the head request correctly, the server will in fact send me a response. So let's see if that one runs or if I fouled it up. Python. All right, I didn't define port. Let's see what happened here. Oh, I called it T-port there, but I called it port down here. This is a very common kind of mistake you'll make. So let's call it, it has to be the same in both places. And so I'll call it T-port in both places. Okay? All right, it worked. This is an HTTP response. 200 OK means I understood your request, here's what you asked for, and all I get is the head, which is the information about the server, like what version of Ubuntu it is and what version of Apache it's using and some parameter settings. Every server sends you this stuff. Your browser does not show it to you because you usually don't care. But this is what the head looks like. Now, if I want to see the whole web page, let's just copy this to get 1.py. All right, if I wanted it to be a GET request, I can just change that head to GET. Let's see what that does. I can do Python, oops, Python, GET, all right. And there we go. Now, I've got a big, long response. Let me scroll back, there. Here's where it started. If you do a GET, you get the head information, and then you get the HTML source code of the page. This is what your browser does. It doesn't show you this, and all that stuff it uses to render the page. So that's a successful GET request. Now, I should mention, yeah, go ahead.
Can you then grep it from the output before you even, if you wanted to just like pull one line of that?
Yes, absolutely. And I could, if you wanted to grep it, grep is not Python, it's Bash. But we'll cover this in the next chapter, but it's good to point this out. If I wanted to find just this line that said, say, vulnerable, I could do this, run my script, and then I can pipe it to grep for vuln. And it will take the output, print it to the screen, but instead of putting it to the screen, it'll put it in a temporary file and then show me only the lines containing the string vuln. So I'll get just the lines that have that string. So that's a fine way to separate. You can also open it in a text editor, put it in a file. There's lots of ways to do it. And you'll have to cope with those when you get output. So this is what your browser's actually doing. What we've written here is the last one you wrote a cheap little port scanner. Now you're writing a cheap little browser. This is like a text-only browser. And this, by the way, is the kind of thing you use if you want to be a search engine. You want to fetch pages and just get the text and scan them for keywords and put them in a database. And you'll use them to hack into login pages. So let's carry on here. There's your grabber. There's the banner. Okay, now, what if you have a login form? So here I've got a login form. So let's try putting in stuff like A and B and logging in. And it says you entered A and B, credentials rejected. So A and B are not the acceptable credentials, but it did send it up to the server somehow. So now it would be nice to see how that went up to the server. Now, my favorite way to do it is Wireshark. You can also use Chrome Developer Tools to do the same thing, but let's use Wireshark for now. This should be a tool you've used before. So you start sniffing the traffic. All right, there we go. I'm getting a lot of traffic. I think I'm going to filter it just down to HTTP. Narrow it down. Now I'm going to log in again with A and B and submit. Okay, and there's some HTTP has gone by, so I'll stop the traffic. Now, right there, it sent a post up to my Python form, and then it sent me an HTTP OK. So this looks like the traffic I'm interested in. Now, you can look at the packets one by one, but they're all full of irritating nonsense like checksums and IP addresses and stuff. All we really care about here is the layer 7 stuff. So you right-click, follow TCP stream. And this will show you the layer 7 data. So this is the easiest way to get a nice readable response, at least somewhat readable. So take a look at what happened here. The red is what I sent to the server, and the blue is what the server sent back to me. So I sent a post instead of header get, and the post said the name of the file I'm connecting to, the version of HTTP, the host, and then some other things the browser sent. Then it sent username and password here, U equals A and P equals B. That's what went to the server. Then the server replied with the header, which is HTTP 200 OK and some information, and then some unreadable junk down here. So that's what my browser sent. Now you could type this stuff into Python, but you don't have to. Python has a cool thing. It has multi-line string variables. So if I want to put this in a Python script, I can just copy it here, the whole thing. And I can just paste it into Python. So let's go back to my browser here. All right, let's copy get to post and nano it. Okay, get rid of the colors. Whoops, I hit the wrong thing. Control C will cancel. Control X. No. All right, let's try that again. Okay, escape Y will get rid of the colors. All right, so now I'm going to make another variable called request. REQ equals, and I put in 3 quotes. Then I paste in the stuff from my clipboard and put in another 3 quotes. This is one very cool feature of Python. All this giant mess, including the carriage returns, is in one variable. So now I connect to the server and I don't try to build the request here, I send it from that variable. So it'll send, now this should duplicate what the browser did. Let's try this. It's going to send that request and then it's going to print whatever comes back up to 1,024 characters. So let's run that one. And there, it worked. It sent the request. This is the reply. It's the same as the reply looked there. I get 200 OK, I get this stuff, and then I get this unreadable junk here. So now I would like to manipulate and read that junk in my script because I'm planning to break into login forms by trying many names and passwords. We're building a brute forcer here. So I don't like this unreadable junk. The reason why I'm getting that unreadable junk is here. Let's go back to my script and get rid of the colors again. All right, notice now you can pay more attention to some of these parameters. The connection keep alive just means that it'll keep the connection alive so we can send more HTTP requests through the same handshake. That's not very important. The content length is pretty important. That's how many letters of data I send. So that matters, but right now that's not the problem. The issue here actually is accept. And its content type, let's move down a bit, see what other choices we've got. Yes, here's Accept-Encoding. This is the problem. I will accept zipped data with either the gzip or deflate method, and that's what that unreadable garbage is. Your server would rather send you the page in a zipped form, and your browser would rather receive it in a zip form to make it faster and use less network bandwidth, and then it unzips it, which is fine for the browser, but it's not fine for my Python script. I don't want to have to Python encode unzipping. Although the libraries do exist, I'd rather just not accept zipped data. So to not accept it, I could figure out what to put here to avoid it, but what's simpler is to just get rid of that line. Now I'm not going to tell it that I will accept zip data, and the default is I want plain text data. So let's run that one. This is still post 1. So if I run that one, now you see I send it to the server, I get the reply, and this is the plain text version of that unreadable junk I had before. So now I can see credentials rejected. And if presumably if I successfully guess the right name and password, I'll see something other than rejected there, like maybe success or welcome or something. So now I've got a plain text browser that I can run that is under my control, and I can now make variations on it. So let's go back here. So now you just sniffed and made your Python script and solved that problem of encoding to get rid of this unreadable zipped stuff. My ad blocker is blocking images on my page. That's a little bit hostile. All right, anyway, all right, now the next thing is I would like to be able to vary the name and password. We got down to here. So suppose I want to put a variable with the name and password. What I'm going to have to do is figure out how the name and password get in there and modify my script to handle that. So let's go here. I'm going to copy post1 to post2.py and nano post2. Because I always keep anything that's working and make another file so you can go back if you have to. So now the question is, how is the name and password being sent up? And here's how it works. You have all this junk, all these parameter fields I really don't care about. Then you have 2 carriage returns to make a blank line. And then you have this U equals A and P equals B. And if you count the characters, it's 1, 2, 3, 4, 5, 6, 7 characters here. And that 7 is this 7. So if I want to send different names and passwords, I put the name here and the password there, and I take the total length and put it there. So I can't just have a fixed string for all this junk anymore. I need to vary this number, and I need to vary that and that. So let's do that. First, I'm going to break it right here with quote, quote, quote. And I'm going to call that first part request 1. So that's the first part of the request. Then I'm going to break it here, 2 equals, that's the next part. And in here goes the middle. I'm just going to get rid of that for now. So now request 1 and request 2, a number goes in the middle. And then down here, I've got U equals A and P equals B. I'm going to break it here. Okay, so now I can build my request. I'm going to say, let's say name equals A for now, and password equals B. So I'm going to have the same thing I had before, name and password of B, but now I can build my request. And the request is request 1 plus name, plus length of name plus length of password plus, I think, 5. Because I know it's 7 when I have a 1 character name and a 1 character password. That's the length. And then I want to put in a request 2, and then I want to put in name, and then and P equals, and then password. There. So that is my attempt to do this, my first attempt. So I hope it's clear. The request 1 has the post and all the junk, then it needs the name. So I put in the length, which is length of name, length of password plus 5. Then I have the rest of the text, and then I need the name and P equals password. That might work. I'm not even going to bother sending this to the server right now because I kind of suspect something might be wrong. I'm going to just print request to see what it looks like. And since I don't even want to continue with the script, I'm going to put exit here. So it's not going to do the rest of my script. This is a trick I commonly use when I have a feeling I'm in trouble. I print out something to see what I've got and see how that looks before going any further. Let's see what happens when I try to run this one. This is Python post2. Okay. Okay, I get in trouble. It doesn't like that command because, as you might have anticipated, I've mixed strings and integers. The length is an integer, the text is strings. You can't just add them together like that. You've got to be a little more careful about it. So let me do this more slowly instead of having so many things in one line. Let's go back here and get rid of the colors for the projector. And take a look at this line that does so much. I'm going to make 2 copies of that line. If I can make this simple, let's just calculate the length. L equals. So forget everything except the length. Let's see if this works. Length of name plus length of password plus 5. Okay, then let's print L and then quit with exit. So it's just going to calculate the length and print it and nothing else for right now. So run that one. Now it worked. I got the 7. So I'm okay. I'm calculating, remember 7 is the right length for 1-letter password and a 1-letter name. So it's working. So we're getting places. Now that I have the right length calculated, what I want to put here is not the length of name and length of password plus 5. I want to just put string of L. That'll be the string version of that length. And that might work. That's looking a little better. So I'm going to get rid of that exit. So it's going to now calculate the request and print it out. And let's see how it looks. And I hope you're seeing the pattern here. A few lines, something you can tell, and test it, and That way errors don't frustrate you. You make progress towards the goal. So now it prints the 7 again. Then it prints the request, which is the post. Here's the 7, and it didn't crash. And here's the U equals A and P equals B. This looks pretty good. I've recreated the request, but now it's more under my control. So since it looks pretty good, let's get rid of these print statements. I don't need them anymore. I don't really need to print the length. I don't really need to print the request. I don't need to exit. I want to, in fact, connect to the server and send it to the server and see what the server thinks of this. So let's see if it works. And it worked. It went up to the server. The server said 200 OK, which means I understood your request, and here's what you asked for, and here's the response telling me credentials rejected. So now I can send variable names and passwords up to the server. So let's change that and see if that's working. Suppose I want to send, let's try one up here at my login form. Suppose I send, there, foo and bar. Foo and bar, this is what Linux people usually use. Almost everything Linux people use is jokes. So if I send foo and bar to the server and submit it, it says, you entered foo and bar, credentials rejected. Not very surprising. That's not the right name and password either. But let's see if my script can do that. Let's nano my script, and let's make name equals foo, and the password equals bar. That's a different length, so see if my length calculation is working. Let's see what happens when I run that. And it worked. You entered foo and bar, credentials rejected. So now I can send anything of any length up for a name and a password. All right. And for this one, I think the right answer is like admin and password or something. Let's see. If you send up A and B, you'll get credentials rejected. So now send root and password. That's the way you make a successful login, so let's do that. Modify my script to use root and password. All right. And now I get successful login. So this is the first homework, where all the steps and all the code are there. Now you know how to send anything you want up to a server to log in, and now you get challenges. So the challenges for this one are over down here in 2x, and there's a few of them. So first, you've got another script. Now, by the way, let me point out the most common mistake people make. They take the previous script and they start sending up these names and passwords to the wrong form. The other form, the only right answer is root and password. Don't skip Wireshark. Your first step has to be to log in here and catch it in Wireshark and find out where it's going. This is not going to the same server process as the other one. So you have a form to log in. So let's just make this A and B and start Wireshark sniffing again. Don't skip this step or you will be frustrated. So I'm going to restart this. Let's clear this. Restart the sniffing. Filter it for HTTP to get rid of all the junk. Okay, now send this one up. Go back to Wireshark and stop it. Right-click, follow TCP stream. And as you might imagine, the last one was login 1, and this one is login 2. Not terribly surprising, but anyway, you do have to go to the right file or you'll never be able to get in. So it sent username of A and password of B, and it got some zip junk I can't read here. But other than that, it's the same as the last one. So by modifying that script, you can prepare a script that will try to log in, and I give you the clues. The username is one of these 4, and the password is a 2-digit number. So you have to try 400 requests to get in. And when you make it, you turn in a screenshot with the right name and password, and you're in. There are a few entertaining gotchas. One I'll mention is if you make a new connection every time, you're fine. It'll be slower, but it'll work. If you make one connection, you can send up to 100 requests before you have to make a new connection. So if you try to be smart and do all 400 in one go, it won't work. I highly recommend being dumb. You know, when I did, there are a couple of problems here. When I And I'd be so I used to be clever when I was a physicist. Then I got in the financial world, and my boss told me to stop being clever and instead get it right, because it's money and it really matters. And he said, you can't just have a complicated formula and the answer. You have to do one step and print it out, and another step and print it out, so somebody can put a ruler on it with a calculator and check it. You have to make it so you can audit the results. And I learned a lesson to stop being clever and instead do what's reliable. There are a lot of problems here. One of the problems is that you have 4 names and 100 guesses here, and you'll find out you can only do 100 connections at a time. So what I did is I just hard-coded the name and tried 100. And then I modified the script 4 times. Try each name separately. There's another problem. The first 10 start with a leading 0. That turns out to be kind of a headache. It keeps trimming that away, and you only have 1 character. There are students that had various brilliant solutions. I just made 2 scripts, one for the first 10 and another script for the next 90. So this is the sleazy stuff that hackers do. That's why real programmers, I got people on Twitter that said I should just be fired, they should get rid of me, I should never teach anything from that book, that's the worst book in the world. Because if you're a serious programmer, you don't do these sleazy things. But if you're a sleazy hacker, you just want to break in, you just do whatever's fast and easy and works, with complete disregard for the elegance and error handling and everything. So this problem, which any professional programmer could solve trivially, I solved by making 8 scripts, because it gets the job done. I remember when I was with the boss, we'd have these complicated things, and I'd do it by hand, and there's only like 200, and he said, you know, if you just do all 200 by hand, you'll get the job done before you figure out how to write that script. And I said, you know, you're right. Often, the answer is to stop being so smart and just get the job done. Anyway, so you got to hack into that one, and then if you go down here, there's another one. This one here, there are 4 accounts, and you have a list of names of people, and you're going to have to guess how the usernames are structured. And when you guess the name and password, you will get error messages that give you some clues. So first, you just have to try some stuff by hand until you begin to figure out how the names are structured and what the rules are for the password. And once you have deduced something from the error messages, you can then write scripts. So you have to break into this thing, and that's the challenge for that part. Anyway, I think I may call that enough for today. I just want to point out, if you want to go further, you have to use virtual machines, which I think you've all used in previous classes. And there's a homework here where you set them up. These are the 3 virtual machines. You have Kali, which is just a standard default Kali. You probably already got one. If not, you download it from Remote Exploit. You've got a Windows 2008 machine, which is different than the one I've used in other classes. This is the same machine, but I've installed about a dozen vulnerable software packages, as specified in your book, so it's listening on a bunch of ports, and you can attack it with all sorts of attacks. That's all it is. So you just download this thing and unzip it. And there's a Linux version of the same thing called Metasploitable, which is just a Ubuntu Linux machine with a whole bunch of vulnerable things listening, so you can attack it more easily. It's basically the same thing as this, but on Linux. So there are VMware versions of all 3 here. If you have VMware Player or Workstation or Fusion, you just unzip these and go. If you prefer to use VirtualBox, go inside Project 3, and there are VirtualBox versions you can download and run. But you got to get some form of virtualization up to do this, and later projects will then be using these machines to attack each other. I think I will show you one thing because it's so fast and easy. It took me 2 days to do this, and it's so easy, it'll make you sick. But this is the Eternal Blue attack. This is a top secret attack developed by the NSA, stolen by the Russians, leaked in March, used to make malware in May that brought down all the hospitals in Britain and nearly brought down the hospitals here, but Marcus Hutchins figured it out and turned it off. He gave a talk at DEF CON and was immediately arrested after that. He's now being held by the FBI here on unrelated charges. They say 2 years before this happened, he wrote some banking malware and sold it, and he's going on trial, and nobody knows what's happening. It's a very unpopular move because his latest thing made him a hero, and we feel like it's kind of ungrateful for the FBI to arrest him, but that's not how the FBI works. You know, they arrest you for what you did 2 years ago, and they don't care what you did last week. They want to put you on trial. Yeah.
Marcus Hutchins?
Yeah, Marcus Hutchins, yeah. His online name is like Malware something. Malware, what is it?
Malware Tech.
Malware Zen or something? Malware Tech, yeah. Malware Tech was his online name, but he got arrested after his DEF CON talk. So even though he did something good recently, he might have done something bad 2 years ago and maybe not, but he's got lawyers and all that jazz, and I guess we'll find out in court. But let me show you. I just wrote this new project, graded on at the end, Eternal Blue. Because This is incredibly easy to do, but it is actually very interesting. This is top secret stuff. Stolen by the Russians and leaked to embarrass the NSA and to cause a crisis, which it totally did. Microsoft responded to this by yelling at the NSA, and a lot of other people did. Why are you making this rotten stuff and not telling us? Plenty of people are pointing the finger at each other over this one. But you can download it and use it. So I've got my Kali Linux machine running here, and I've got my target over here, which is the same target you're using, a Windows 2000 machine. This machine, among other things, is got file sharing turned on, which is all you need for this, SMB. And so I put the Eternal Blue up here, and I'm just going to get the series of commands. I think I took them away, but this one is so easy, it's hardly worth anything. It took me like 2 days to figure out how to do it, but once you've figured it out, it is just a few commands. What this does, this is Git. This is how you copy other people's code these days. Everybody puts their code on GitHub. You totally need a GitHub account. You should make one. You aren't going to make any code in this class worth putting there, but it's a good thing to have. Even if you don't have code to put in it yet, you should be in the club. So you have, this guy is named Warowit, whatever that means, that's his name, and he put up this thing called MS-1710, which is Microsoft's code for the Eternal Blue NSA attack. So you clone his repository. Let me just do these one by one and explain them, because it's very simple. Git is your best friend. It is so much better than downloading stuff in a browser and unzipping it or anything. This automatically does what you want. Start in some directory. Let me just remove the old one. Okay, I'm going to git clone the repository. So it goes to the network, receives a bunch of junk, and it appears. So now if I do a list, I now have a folder called MS-1710. If I go in there, I have files. Okay, there are a bunch of Python scripts that do the attack. And so all you have to do is run a Python script to do the attack. There is one other dirty trick, though. The attack wants you to feed in binary shellcode. And there's a directory called Shellcode. So you might think that the author of this gave you the shellcode, but what he actually gave you was ASM files, which are assembly language, not compiled. I have 64-bit and 32-bit assembly file shellcode. And I was having trouble figuring out how to compile it and what format it should be in, so I just Googled online. I got far enough to get an error message, then I Googled the error message, and I found somebody's blog that showed me how to do it. And so, here's the command that compiles it. I got almost to this command, but I hadn't got it all figured out. This is what compiles to shellcode. NASM is the assembly language compiler, and you put it in binary. So I compile that, the x86.
Do you have to do each one of those two, the 64 and the 86, or just one of them?
The one that matches your target, and this target is 32-bit. So if you had a 64-bit VM, you'd use the other one. Good? All right, so now I do that, and that's just going to compile it. Now if I look in there, now I have the assembly language files, and here's the actual compiled version without the ASM extension. So now I've got compiled binary shellcode, and it's only 638 bytes long. The source code is much bigger, which is normal. Machine language is usually a lot smaller than source code. So now, that shellcode, so-called, just starts the attack, but it doesn't do anything. You have to add to it more binary that does something. And as you've used, I think, in previous classes, we're going to use Metasploit a lot here. Metasploit is awesome. People use Metasploit to do all the hard work of hacking these days. So instead of figuring out how to write assembly code, I just use MSF Venom, which can make any of 100 attacks work. So I'm going to use Windows Shellbind TCP, the simplest attack that just opens a listening port, and you don't even have to specify the number. If you don't specify the port, it's 4444. So this is going to create shellcode in raw binary format and call it bind86.bin. So that's what that does. When I run that one, it creates a file. If I do ls-l, I have this thing. Where is it? Bind86? Hey, I don't see it. Or I did something wrong. All right, I'm going to look at this command again. Oh, I did the NASM. Okay, this is a mistake of my Mac. My Mac fails to copy and paste correctly frequently. So I repeated the compiling in the last one by accident. It doesn't hurt to do it twice. That's the one I wanted, the MSF Venom. MSF Venom takes a few seconds to run because it's written in Ruby, which is interpreted rather than compiled. and there it goes. It created a 328-byte file called bind86.bin. And let me point out, let's go to my target. This is my target machine. I do need to know a few things about my target. Let's do ipconfig. Okay, and let me see if I can make my font bigger. Properties, font. That looks pretty good. All right, so my IP address is 172.16.1.191. I'm going to need that. And the other thing I'd like to do is look at my listening ports with netstat, with only one S, minus AN pipe more. Okay, let me make that so it fits on the screen better. Okay, here's my listening ports. I'm listening on a lot of ports: FTP, SMTP, HTTP, Windows file sharing, and a bunch of other junk. But one thing I am not doing is listening on 4444. 4444 is not there. So right now, my box has a bunch of vulnerable services, but not that one. So let's go back to here and do the attack. I have to combine the two shellcodes together. This is the eternal blue shellcode that came with the attack, and this is the additional code I want to execute that's going to start listening on 4444. So cat will just combine those two files together into one file, which I called sc86x86.bin. I couldn't call it anything, but that's the name I chose to call it. That's my combined 32-bit attack code. And if I do ls minus L, you'll see that my bind was 328 bytes, but my shellcode is 966 bytes. This attack has a maximum size of about 2,000 or 3,000 bytes. You can't have more than that. That's all the room there is. This is in fact a buffer overflow in SMB, but it's one that Microsoft never found. The NSA found it and used it to take over everybody until the Russians stole it and leaked it. They would still be cheerfully taking over everybody with it if the Russians hadn't done that. But now Microsoft put out a patch. So this is only going to affect you if you didn't patch in the last few months. So now I run the attack, which is Python and the name of the attack. And if you run it that way, it'll give you a help message telling you, well, this is very common. It tells you, here's how to run it. Run this, then put in the IP, then put in the shellcode, and then you can have some number of connections that's optional. Square brackets means it's optional. So that's why I needed to figure out how to make the shellcode. So I have to specify the IP address and the shellcode. So I do that, and now it runs. And you notice this one failed. It killed my machine. Blue screen of death. This is fairly common. This particular exploit is pretty well known for this. Sometimes it kills the target, and sometimes you win and get in. So I made this thing so it doesn't bug you about shutting down and restarting, and it automatically logs in, you know, because you're going to be doing this a lot. A lot of these attacks are unhealthy and kill the machine, but I got it to work at least once earlier, so I might be able to make it work once in front of you, and maybe not. Let's let this thing boot up. All right. Now it's recovered from an unexpected shutdown. Yeah, it sure has. I'm aware of that. Windows doesn't need to warn me. This is one of the vulnerable services listing. I don't care about that. I'm just going to run the same thing again. And this time, it didn't kill the machine. Let's see if it worked. If I open up another command prompt, and I do netstat minus an pipe more, there it is. It's listening on 4444. That's the result of my shellcode. That means anybody can take over the machine with just netcat. I do netcat to its IP address, which is this, on 4444, and I'm in a Microsoft operating system. Who am I? I'm system, and system, as you may know in Windows, is the most powerful account, more powerful than the administrator. System is the account that runs the system before you log in. It can do anything. There's stuff the administrator can't do, but system can do anything. And this is a buffer overflow in SMB. So as you see, I'm glad you got to see the whole thing. It's not terribly reliable. It kills the machine sometimes, but when it works, you're in. And that's the game here. And you'll be doing a lot of attacks like that. So that's what I wanted to show you to motivate you to get your virtual machines running. If you want to work on any of this stuff tonight, I'll go to the lab for a while, or you can just go home. Nothing is due for several weeks, so you got plenty of time to get going. If you need ad codes, I've got them up here. There should be an attendance sheet somewhere. Good, okay. So let's make sure you get your name on that, just so I know you're here. It doesn't really matter, but the college likes me to report how many students show up in class or something, so it's a good idea. Here, why don't you pass it up? So before you leave, please put your name on the attendance sheet. And there's a sheet here you can put your address on if you want information about the hacking club, although I think he might want you to put it in his computer. And I'll just answer questions. Yeah.
Just a quick question. So, quiz 2 and 4 only, or 2, 3, and 4?
2 and 4, 3 and 5 are the next time.
Okay.
Because what happens is they have to cover a couple chapters before it's time to make them due. So it's a little out of order. And this is all on my website. It's also in that printout. Good. If anybody needs an ad code, come up here and I'll give it to you. If you got any other questions, let me know. But that's it for today. I will go to Science 214 to help anybody that wants help tonight.